So to download or upload any file from the torrent network, we need a .torrent file. But what exactly is this file? In this second video of the BitTorrent internal series, we take a detailed look into the .torrent file and understand its life cycle, what information it holds, and the encoding that it uses to structure the data internally. But before we move forward, I'd like to talk to you about a course on system design that I've been running for over a year now. The course is a cohort-based course, which means I won't be rambling a solution and it will not be a monologue. Instead, a small focused group of 50-60 engineers every cohort will be brainstorming systems and designing it together. This way, we build a solid system and learn from each other's experiences. The course to date is enrolled by 600 plus engineers spanning 9 cohorts and 10 countries. Engineers from companies like Google, Microsoft, GitHub, Slack, Facebook, Tesla, Yelp, Flipkart, Dream11 and many more have taken this course and have some wonderful things to say. The coolest part about the course is the depth we go into and the breadth we cover. We cover topics ranging from real-time text communication for Slack to designing our own toy load balancer to ClickBuzz's live text commentary to doing impressions counting at scale for any advertisement business. In all, we would cover roughly 28 questions, and the detailed curriculum split week by week can be found on the course page, which is linked in the description down below. So if you're looking to learn system design from the first principles, you will love this course. I have 2 offerings for you. The first one is the live cohort based course, which you see on the left side, and the second one is the recorded course, which you can see on the right side. The live cohort based course happens every 2 months and it will go on for 8 weeks, while the recorded course contains the recordings from one of the past cohorts as is. If you are in a hurry and want to binge learn system design, I would highly recommend you going for the recorded one. Otherwise, the live cohort is where you can participate and discuss things live with me and the entire cohort and amplify your learnings. The decision is totally up to you. The course details, prerequisites, testimonials can be found on the course page arpitbhayani.me/masterclass, and I would highly recommend you to check that out. I put the link of the course in the description down below. So if you are interested to learn system design, go for it. Check out the link in the description down below, and I hope to see you in my next cohort. So when a user wants to download any file from the torrent network, it needs a .torrent file. .torrent file holds the information about the file that the user wants to download. So for example, if you'd want to download an Ubuntu operating system from the torrent network, that Ubuntu operating system ISO image would have a torrent file. You download the torrent file which would have the meta information about the particular image, and then you can go to the network and download the file with the usual flow. So the life cycle of a torrent file is pretty simple. Seeders are seeding the data in the network, right? And so long as you have at least one seeder in the network who is serving the file, your torrent is alive. Otherwise, your torrent is dead, right? So it's very important in your network to have at least one seeder. Otherwise, no one would be able to download it, right? And what separates this P2P network from a classic blockchain/cryptocurrency use case is that with P2P, with BitTorrent, there is no incentive for anyone to join a torrent and become a seeder, because seeder is the one who is seeding the content, leecher is the one who is downloading. Cryptocurrency incentivizes you being part of the network. BitTorrent doesn't, right? This is one differentiating factor between the two. And when now the overall flow that it looks like, it becomes something like this. User first downloads a torrent file from a website. Let's say you want to download Ubuntu image. You go to ubuntu.org and you can get the .torrent file from that. And then you use your client. Let's say you'd use BitTorrent client and open the file in the BitTorrent client, and it would start downloading the file from the P2P network of that particular Ubuntu image, right? And then once your download is complete, there are 2 choices. Either you can continue your BitTorrent client and become a seeder, because now you hold the file. So you can now seed the file to the network if anyone wants to download it. Otherwise, you can just discard the torrent file and just basically kill your process, right? So that's where the default configuration is. Once your file is downloaded, you automatically from leecher become a seeder and you start seeding the content there. Right? Now let's take a look at what is there in the torrent file. So torrent file is a static file. So no matter when you download the file, it would have the exact same content. It holds the meta information about the file instead of the actual data. So in the Ubuntu images torrent file, it would have the information about the image and not the data of the image, right? So what it holds? the most critical thing it holds is called as announce. Announce is the announced URL of a tracker. Remember, torrent network is not a pure P2P network. There is a central entity called tracker which keeps track of which all peers have what kind of data. Right? It holds that information. So given that it holds that information, for a user to download the path and join the network, it needs to know which tracker is every node sending data to. Right? When I say data, it's the metadata sending to that. Hey, I am the node and I want to be part of this network. All of this information is stored in a tracker, which is a simple HTTP server, and this tracker has a URL. Whoever wants to join the network needs to talk to the corresponding tracker, but which tracker? That it would find in the .torrent file. So if I want to download an Ubuntu image, I'll download a torrent file, I'll read the announce, I'll get the URL, and that is the tracker that I'll talk to, right, for that particular file. Second is meta info, like created by, like who, like which program created it, creation date, as in when this torrent was created. Then encoding is the encoding of the strings. It by default it's UTF-8, but if there is some other format you can have it. Then comment is just description about it. Then comes a very important information called info. So the torrent file that you have is just a dictionary. It's just a dictionary of key value pairs, where first 5 keys that I talked about is announce, created by, created date, encoding, comment. The 6th one is very important. It's called info. Info is a dictionary. So it's a dictionary within a dictionary. And what it holds is it holds the information about the file itself, which means if I'm downloading the Ubuntu image, it would contain the information about the Ubuntu image itself. So what it holds. So you would have seen that in torrent, there are 2 types of downloads. First is a single file download. Second is a multi-file download, right? Because you might want to download a folder from the torrent network. So you can also stream a folder content directly instead of just a file. So there are 2 types of thing that it supports. It's a single file or multi-file. So depending on what you have, the structure of your dictionary might change. The structure of your info dictionary would change. So in a single file format, it would have the name of the file, the length of the file, which means how big your size is. So let's say Ubuntu image is, let's say 600 MB. So it would be 600 something. The length of the file, the MD5 sum of the file, so that you can validate if your file is downloaded correctly or not. That's a single file format that has 3 fields in the info dictionary. Then if you are streaming multiple files, or you are streaming a folder that has multiple files, what you would have is you would have a key called name that would store the name of the directory. Then files. Files is a list of directory, one for each file, which means it would be list of dictionary, not directory. Files is a list of dictionary which would contain information about each file in the particular directory. So now let me simplify it for you. You have a directory that you would want to put out in the torrent network. That directory would have a name. The name field in the multi-file format holds that information, right? In that directory, you would have multiple files that you would want to put out, right? So for each file, you would have a dictionary entry made in this info dictionary, and each of that entry would have the length of that particular file, the MD5 sum of that file, and the path of the file. In, like, for example, if I have a dictionary that if I have a directory that I'm serving, in that directory, I have a file a.txt, b.txt, and c.txt. That's what I'll store. So I'll have one dictionary entry for a.txt, one for b.txt, and one for c.txt, right? And I would store the path relative to the root path, right? Once I have this information, this is what I'll use to, then I can just fire my normal, I can upload this torrent into my client and it will start downloading the content, right? But one very interesting thing, the way it stores the path of the file, for example, if I have path like /a/b/c.txt, in the torrent file, it would be stored as a list of strings a, b, c.txt. Instead of storing /a/b/c.txt, it just stores it as a list of strings a, b, c.txt, because of the operating system separator. Like every operating system has a different separator. So why to store like / only in the Unix format? If it's Windows, it might be something else. If some other operating system is there, is something else. So thinking about that, they store the path as as list of strings that take you to that path. It's a very important design decision that they took, right? Now we saw the meta information there, but where it's still not complete. How would I know where to download from? Like, where are the pieces in the blocks? This is where in the info dictionary itself, there is two very important fields which are like super critical. First is piece length and second is pieces. So piece length, so we know that a file is split into pieces and each piece is then transferred as a block. So we need to store somewhere that this file has these pieces. This is also part of a torrent file. So what you do is a file is split into equal pieces. The piece length tells you how big a piece is, right? So this is the piece length. For example, I can have a 1 MB piece of my file. Let's say I am having a 1 GB file that I'm putting out on the internet. I can have a 1 MB piece. So I'll have 1000 entries or 1024 entries for that, right? And each piece length is 1024 MB. So this is stored in bytes. So it's 1 MB, it's 1024 something, right? It would store that much, that value there as a piece length. And then the actual pieces. So the actual pieces that it stores, it does not, obviously the torrent file would not hold the data otherwise. Why? What it would do is, for each piece that it has, it stores a 20 byte SHA-1 hash of it and concatenated across. So for example, if I have a file that has 3 pieces, right? If I have a file, let's say if I have a file of 3 MB, right? And my piece length is 1 MB. Right. So what I'll have total 3 files, right? I have 3 pieces of my file. So what would happen is I'll take my first piece and I'll pass it through my hash function, compute the SHA-1 hash of it. Let's say it is S1. I'll take my second piece, pass it through the hash function, I'll get S2. I'll take my third piece, pass it through the hash function, I'll get S3. And what I'll store in the pieces is concatenation of my SHA hashes. So my pieces would be a 60 byte array in which I'll have 20 byte for each piece that I have. So that's a SHA-1 hash. So S1 concatenated with S2 concatenated with S3. And my piece length would be 1 MB, right? So piece length is 1 MB. Pieces would have 60 bytes of storage where each of the 20 byte holds information, is the SHA of the corresponding piece. Right? And this is this is exactly the information that you are storing in your .torrent file. And this is what would help you get, hey, now that I have a torrent file, do I have all the pieces with me or not? The pieces that I would not have, I'll go to the peers and download the corresponding piece. And then I'll just concatenate it locally to have my entire file ready. Right? And this is what your .torrent file stores. The .torrent file, the two most critical information that it stores is a piece length and pieces. Pieces is just a concatenation of 20 byte SHA-1 hash of all the pieces of your particular file. But how it actually stores or what encoding it uses to store, to create that file. When I say dictionary, it's not JSON. It's not JSON. It's something called as B-encoding. Right? So all the torrent files that you have, they are B-encoded, and what they do and what you have to do is when you download a torrent file and when you add it to your torrent client to download the actual file, what it would do is it would first decode the .torrent file and understand the information that we just discussed, like what's the announce URL, what are the pieces, what is the piece length, who created it, and other information. Right? So it would need to read the .torrent file to extract this information. So that is where it would pass it through a small decoder, and which would give you the torrent information in the human or into the processable format, right? And this decoder is a B encoding decoder, right? So the encoding is called B encoding. It's a very simple encoding and a very fun one to write, right? So what is a B encoding specification? So every torrent file is B encoded and it's a dictionary. So torrent file is a dictionary of key value pair that we just saw, and how the B encoding specification, it supports only 4 types: strings, list, integer, and dictionaries, right? A string is formatted something like this. It has a format of length, string. So for example, if I want to store Arpit, ARPIT would be stored or would be encoded as 5:ARPIT. So 5 is the length because Arpit has 5 characters. So 5:ARPIT. So if I'm having a B encoded string, what I would do is I would first read until I hit a colon. I would interpret this as a length, and then I would read those many bytes and then interpret it as a string. This is what a B encoded string looks like. Second, B encoded integers. B encoded integers are stored as I, then your actual integer, and then E for end. So integer start, then your integer, and then integer end. So if I want to store 10, it would be stored as I, 10, E. Integer start, then up until E, whatever is there is my integer, and then as soon as I get an E, that is the end of an integer. So representing 10 in my B encoding would be I, 10, E. Right? Then the third type is list. List could store any B encoded values. Right? So B encoded values could be string, int, list, and dictionary. So the format that a list holds is L, then B encoded values, and then E as an end of the list. So if I want to store a list of string A, string B, and an integer 1, what I would have is I would have L, 1A, 1B, I'll have L, 1:A, 1:B, 1 I, 1E, right? Because I have first as a string of, I'm storing A, which is of 1 character, the length is 1 character, so I have 1:A. Then my second element is B, so that 1:B. Then my third element is integer 1, so I, 1E, and then at the end E to end my list. So that becomes my list encoding. So a list of string A, string B, and integer 1 is encoded like this. And then final element, final type that it supports is dictionary. Dictionary is D, and then B encoded string, then B encoded value, and a repetition of it, basically storing the key value pair that you have, ending with an E. So D and E, and within that you would be having key value that you are storing, and key has to be an integer. It cannot be anything else. So for example, if I'm storing a dictionary of keys where keys I have is string A with value 1, string B with value 2. My dictionary, which is B encoded, would look something like this. D, 1:A, I, 1E, 1:B, I, 2E, E. Right? So my dictionary ends. So my dictionary starts with a D, ends with an E. Within that I have a key A. So A is a string. So 1:A. Value is 1 as an integer. If 1 is an integer, so it would be I, 1E. Then key is B. B is 1:B. And then 2 is I, 2E. Right? So key value, and this would be my B encoded dictionary. So your torrent file is nothing but a dictionary of all the attributes we discussed, like announce, created at, creation date, created by, pieces, piece, info, all of that. So it's a B encoded dictionary. So entire torrent file is B encoded. So if you write a small parser, a B encoding parser, you can parse your torrent file itself. And to be really honest, it hardly takes 15 minutes to write a B encoding parser, but I would highly encourage you to write one. Right? I'll share the link of the GitHub repository where I wrote my own B encoding parser, hosted on GitHub. I'll put the link of the repository in the description down below so that you can basically validate and see how easy it is to write it. You just have to write a small recursive parser to parse the B encoding files, and once you do that, you can read your own torrent file and extract the information and then start writing your client. And that would be our first step. Like when you get the torrent file, you first need to understand the information of it and then start downloading the file from elsewhere. Right? We'll do that. So yeah, it's very fun to write your B encoding parser. I would highly encourage you to write one. It's very simple. You'll have fun writing it, to be honest. Right? So yeah, and that is how your torrent file is structured, is encoded and serialized in the format that anyone in the world can understand. So anyone in the world who can understand B encoding can understand the torrent file and then extract the information out of it and then do whatever it wants to. Right? and the information that it holds, announce, pieces, piece length, very critical information. Using that information, it would start downloading the file, which we'll talk about it in the next video, right? In next video, we'll talk about the basic architecture of BitTorrent and how each of the component plays and what it does and how it does what it does, right? So yeah, that's it. That's it for this video. If you guys like this video, give this video a thumbs up. If you guys like the channel, give this channel a sub. I post 3 in-depth engineering videos every week, and I'll see you in the next one. Thanks again.